This is Unit 6b. It deals with thermistors, light-dependent resistors, combining resistors, and potential dividers. So starting with thermistors and light-dependent resistors, the thing they have in common is the resistance varies according to outside conditions, and by those conditions we mean the amount of energy available. So here, in the case of the thermistor, it's heat. In the case of the LDR, it's light. So in both cases, this extra energy from outside makes more electrons available. So here we can see the thermistor in cold conditions, and it's holding on to its electrons. It's very difficult to get a current flowing, only a few electrons available there to form a current. Here we have lots of energy coming in. We can see it's warmer, we can see them moving around, and we can see they're holding on to less of their electrons, fewer of their electrons I should say. Lots of electrons, lots of opportunity for a current to flow. On a diagram we can see that here, temperature's increasing, resistance is decreasing. Exactly the same picture here, more energy, more light energy, less resistance. Again, here it's dark, not many electrons available. Here it's light, lots of energy, they release the electrons, and passing a current becomes much easier. In other words, resistance is low. Here then we have combining resistors. Now the word combining is very important actually, because saying adding is quite misleading. Well, half the time it is anyway. When we have resistors in series, adding is the right idea, it's the correct concept, and mathematically we can see that there. But in terms of what's going on, it's because we're adding a constriction. Every time we put another resistor, we're making it harder. Think of a garden hose. More and more people standing on the garden hose, it's going to make it harder and harder for the current to flow through. So this is the key image to have in your mind. However, when it comes to resistors in parallel, that image isn't helpful. What we should think of is people leaving a large room, or a lot of people leaving a stadium or something like that. Big door open, and then we open another little door. Now it's not great, but it does add to the ability to leave, so it actually reduces the resistance. And mathematically we can see that here. It's a little bit more complicated. So there we have one resistor, and we add another resistor, and the bigger this resistance is, the less good the path is. So it's 1 over, so this expression here is the conductance. So we're adding conductance, but the bigger the resistance is, the worse that conductance is. So we add up all the conductances together. It can be 2, 3, 4, whatever, and that will give us the total conductance over here. But what we're usually interested in is the total resistance, so that's going to be 1 over again. So it's a bit tricky to get your head around, but that's why we have this animation. As long as you keep this clear in your head, we know that when we add the 20, the overall resistance will be less than 10. So you really must try and keep these two cases separate in your mind. So here we have the potential divider. By potential we mean electrical energy potential between 2 points, also known as voltage, often abbreviated to PD as well. So it really is just two resistors in series, as we can see here, and we're interested how changing the resistance of one and changing the resistance of the other influences the voltage across the second one. So there's quite a lot going on, so we'll take it reasonably steadily. So here we've got the lower resistance. In this case our example is a thermistor, but it could be any kind of resistor, is increasing. Obviously it doesn't really increase and decrease in size, but it just tries to make it vivid for us. Now our key concepts here are share of resistance, share of voltage, and adjustable threshold. So as this changes, its share of resistance changes, and this little term here allows us to see this. So R2 is its resistance, the total resistance is R1 plus R2. So as it increases, the total resistance obviously increases, but its share increases as well. Imagine R1 is 10, and then R2 goes to a very high number like 1,000,000. Then you can see that it's 1,000,000 over 1,000,001, and it has by far the biggest share. Now V in here is the total voltage across here, the total energy going into the system. So this isn't changing. but when the share of resistance changes, it demands a bigger share of the voltage. So as this expression increases, so does the V out, which is the voltage across here, and that voltage can be tapped off to do something, as we'll see in a second. So over here we've got the same circuit, or the bit of a circuit, but now we've got this resistor here changing. It's a variable resistor, and it's kind of obvious that if its own resistance changes, its share changes. What's less obvious is if something happens far away, or not very far away, but you might think it might have no effect, but it does. And we can see that here. So R2 isn't changing, R1 is changing, but this does change the proportion of the resistance, first of all, that R2 represents. So the bigger R1 gets, again, think of a very high number, think of R2 being 10, this goes up to 1,000,000, then suddenly R2 is a very small proportion of the resistance, and that's what this term expresses. And again, because V in is constant, that is going to influence the V out, the share of voltage across here. Now, in terms of what's actually going on, we've got a summary here. Remember, this is a thermistor in this particular example. So temperature goes down. So let's imagine this is a thermostat controlling a heating system. Resistance goes up, and therefore V out also goes up, and that's going to have some kind of consequence, like switching our heater on. But our third key concept here is adjustable threshold, and that's where this variable resistor comes in, that by adjusting this, we can adjust the level at which V out reaches the critical value that switches on a heater. So there's quite a lot going on there. Do try and take it in, do watch this video a few times, but as I say, the key ideas are share of resistance, which can change in two ways. Either you change, or something else in series with you changes. That changes your share of resistance. That changes the share of voltage, and that can have some kind of consequence. Switch on a fan, a heater, whatever. And adjustable threshold, this variable resistor can adjust the trigger point at which that happens.